You do it 100 times a day, probably without even thinking about it. You visit a website. But behind that one simple click, there's a secret language at work, a hidden conversation happening between your computer and the internet. Today, we're going to pull back the curtain and learn how to speak it.
It really does feel like magic, right? You type a few words, hit enter, and bam, a whole world just appears on your screen. But it's not magic. It's an unbelievably fast, perfectly choreographed dance of technology. And we're about to learn all the steps.
So what's really going on? Well, at its very heart, the whole thing is just a conversation, a really, really fast one. Your browser, the client, asks a question, and way out there on the internet, a big computer, a server, gives it an answer. That's really it. But the language they use to talk to each other is very specific.
Okay, so if it's a conversation, what language are they speaking? You know, for any chat to work, both sides have to agree on the rules, a shared protocol. And for the web, that secret language is called HTTP.
Honestly, at its core, HTTP is super simple. It really just boils down to two types of messages. Your browser sends a request, and the server sends back a response. That's it. That simple back and forth is the foundation for absolutely everything you do online.
All right, let's play detective and break this conversation down. We'll start with the browser side of things, the request. What is your computer actually saying when it asks for a web page?
Well, every single message, and I mean every single one, whether it's coming or going, follows this exact same four-part structure. There's a start line with the main command, then a bunch of headers with extra info, a required blank line to separate things, and sometimes a message body with the actual data.
So let's look at a real one. That very first line is the main command, and 9 times out of 10, it's going to start with the word get. It is by far the most common command in HTTP, and it's super straightforward. It's just your browser saying, "Hey server, please get me this specific file."
After that main command, you've got the headers. Think of these as little sticky notes with extra information, and one of the most important ones is the host header. The analogy of an address on an envelope is perfect here. You see, a single server out there might be home to hundreds of different websites. This header is crucial. It tells the server exactly which one you're actually looking for. Then you've got this other key header, the user agent. This is basically your browser introducing itself at the party. It's like, "Hey, I'm Chrome running on a phone," or "Hi, I'm Firefox on a desktop." And this actually matters a lot because the server might use this info to send back a special version of the site that's perfectly formatted just for your screen.
Okay, so that's the browser's request. Simple enough, right? Now let's flip the script and look at the other half of this chat, what the server says back. The server's reply also has that single, crucial start line. And the most important part is this little number called a status code. Now, the one you want to see, the best case scenario, is 200 OK. It's basically the server giving you a big thumbs up, saying, "You got it, found what you asked for, and everything's great."
But of course, things don't always go perfectly. I am sure we have all run into the dreaded 404 not found. That's literally the server saying, sorry, I looked everywhere, but that page just isn't here. And if you see a 500 server error, that's the server kind of raising its hand and saying, yikes, you did everything right, but something broke on my side. These codes are just a really fast way for the server to tell you what's up.
And just like the request, the response has its own set of headers. I like to think of these as the packing slip on a package. They tell the browser everything it needs to know before it opens the box. You know, what kind of file is inside, exactly how big it is, and sometimes it even includes a little name tag, what we call a cookie, so the server can remember who you are next time.
Okay, we're at the final and maybe the most amazing part, actually building the page. The conversation is over. The server has sent back a big chunk of HTML code, but right now it's just plain text. It's your browser's job to perform the real magic and turn that blueprint into the living, breathing web page you can actually interact with.
The easiest way to think about it is like building a house. Step 1, the browser gets the HTML. That's the architect's blueprint. Step 2, it uses that blueprint to build something called the DOM. That's like putting up the wooden frame, the walls, the whole structure. And finally, step 3, it runs the JavaScript. That's like flipping the switch and turning on the electricity, bringing the whole house to life.
And here is the really cool part about the DOM. It's not a static document anymore. It's a live, interactive model of the web page living right inside your browser's memory. And because it's live, JavaScript can reach in and change things on the fly, move a wall, paint a room a different color.
That's how you get all those amazing animations and dynamic features on modern websites, all without ever needing to hit the refresh button.
So wait a second. You've got all this code from some random website running right there on your computer. How is that not incredibly dangerous? Well, there's one fundamental rule that keeps everything safe, and it is probably the most important security concept on the entire web. It's called the same origin policy.
The idea is actually super simple. Think of your browser tabs as separate, soundproof rooms. The same origin policy is like a bouncer at the door that makes sure the code running in your social media tab can't peek through the keyhole into your online banking tab. Each site is locked in its own little security sandbox. It's pretty much the only thing preventing total chaos online, and it's absolutely critical for keeping your data private.
Okay, just one last piece to this whole puzzle. We've talked about the language, but for any conversation to be perfect, there can be absolutely no room for misunderstanding. The message has to be crystal clear.
So here's a problem. What happens when you need to send a character that already means something special in this language? For example, the less than symbol is a fundamental part of HTML. If you just stick that inside a URL, the server or browser might get really confused. So how do we get around that?
The answer is something called encoding. You can think of it as a translation service. Before any message gets sent, the browser looks for any of these potentially confusing characters and translates them into a safe, unique code that won't cause any problems. And what's really interesting is that the code is different depending on the context. See here? The same less than symbol gets translated one way for a URL and a totally different way for an HTML page.
So at the end of the day, all this encoding stuff is just about making sure nothing gets lost in translation. It's the thing that guarantees the conversation between your browser and the server is perfectly, unambiguously clear every single time. And that's the whole journey, from that initial GET request your browser sends out to the server's happy 200 OK response, all the way to building that living DOM and firing up the JavaScript. It's all just one big, super fast, highly organized conversation. And it happens every single time you click a link. So now you know the secret. You speak the language of the web. And I've got a challenge for you. Next time you're on your computer, open a website and just hit the F12 key. That'll open up the developer tools. Find the network tab, and you will see this entire conversation we just talked about happening live, right before your eyes. You understand the language now, so the only question left is, what else are you going to discover?